This is a lesson for 2-4, day 1. What we're doing today is setting up compound inequalities and graphing them on the number line. So a compound inequality is an inequality that is formed by the union, which is an or statement, or the intersection, which is an and statement of two simple inequalities. So basically what you're doing is you are graphing two inequalities from a problem situation on the number line at the same time. Sometimes those arrows are going to come together in the middle. That is an and statement. Other times they're going to go out, which is an or statement. So let's take a look at what some of these look like. First of all, taking a look at an or statement. It says you have a doctor appointment from 1 o'clock to 3 o'clock. So you're there at the doctor's office from 1 to 3. You want to go biking with a friend. You can bike before 1 o'clock or after 3 o'clock. So if we go to graph this on the number line, you're available before 1 o'clock. Let's assume that the doctor's appointment starts at exactly 1 o'clock and 0 seconds. So you are free before that. So you're free all in this area, less than 1 o'clock, right? Because you're free before that, but not including 1 o'clock. You're free up until 12:59 and 59 seconds. But as soon as 1 o'clock hits, boom, you're not free. So that's why we're using an open dot, because it doesn't include that 1 o'clock time. And your doctor's appointment goes all the way till 3 o'clock. So right at 3 o'clock, you're still at the doctor's appointment. All right, so that's going to be an open dot. But then after 3 o'clock, you are free again. So 3 o'clock and 0 seconds is exactly when you're done with the doctor's appointment. So 3 o'clock and 1 second, you are free to go biking again. So that would be an or statement. Notice how those arrows go out, because anytime less than 1 o'clock or anytime greater than 3 o'clock, you're free. Take a look at the and statement. You're buying a new pair of sneakers. The least expensive pair is $35 and the most expensive pair is $200. So $35 includes that 35. So 35 is a price, and it goes more than that, right? Because that's the least expensive that it could be. The most expensive is exactly $200. So it includes that. So that's why we're using a closed dot, but it could be less than that. Well, these two arrows are going to collide in the middle. Because they collide in the middle, we don't leave our graph like that with two arrows. What we actually do is we connect it using a bar or a line right in the middle. So those pair of sneakers that you're looking to buy are anywhere in between and including $35 to $200. So they could be $75, they could be $130, but anything in between there, right? Let's take a look at some more word problem type things. So taking a look at shipping. What is the least amount a customer can spend on items and pay $6.50 for shipping? So if we take a look at our table here that has our shipping costs, anywhere from the cost of an item, anywhere from a penny up to and including $20 is a $6.50 shipping fee. So what's the least amount a customer can spend on items and pay $6.50 for shipping? That would be 1 penny. What is the greatest amount a customer can spend on items and pay $6.50 on shipping? Well, it says up to and including the keyword there, $20. So this would be $20. What is the shipping fee if Sarah spends exactly $75 on items? So between 50 and 75 is $11. So that doesn't include 75, but from 75 up to but not including 100, they pay $12.25. So this would be $12.25 because that includes the $75. So let's take a look at what these are going to look like on the number line in statements here. So there are two different ways that you could write a compound inequality. You might see it written like this with the word and in the middle, or you might see it look like this with an X in the middle. These are both and statements. These are both and statements. So this inequality is read as all numbers greater than 2 and less than or equal to 7. This inequality can also be written in the compact form like this. So if we were to go and graph this, we're graphing two separate inequalities at the same time. We're going to have a dot at 2 and a dot at 7. So I'm just going to put an open dot and an open dot to start. But when you really take a look at the inequality statement, notice that we have an or equal to right here by the 7. Anytime that you have the or equal to, that is a closed dot. Anytime you have the or equal to, that's a closed dot. Anytime that the letter is in the middle, that means the bar is going to connect these two because we're looking at all the possible numbers in between 2 and 7. Now, notice that this doesn't include the 2 here. All right, this doesn't include the 2. So that's why we have an open dot. So anything from like 2.00001 all the way up and including 7.0. So that's what this looks like. If we have this, notice that we switched around the inequality sign here, because when you go to write an inequality and statement, the order goes the number, the smallest number first, then the inequality sign, then the letter, then the inequality sign, then the biggest number. The smallest number always goes over to the left. The biggest number always goes over to the right. That's how it's written, with the letter in the middle. You are always going to have less than symbols. All right, these are always going to be less than symbols. Now they can be less than or equal to. All right, but they're always going to be less than symbols. The reason why is because we want this first dot going over to the right when we draw it on the number line. So in order for that to happen, you have to have this greater than symbol here. All right, if we write it out like this. Well, when you flip around an inequality, you have to flip the sign with it. So by having that X in the middle, we had to flip everything around, including the sign. That's why it's always going to be a less than symbol there. And then the second one, we just bring straight down. All right. But this first one, we would have to flip around. This is always going to be a less than symbol. So again, the smallest number is always on the left. The biggest number is always on the right. But this is what your and symbol looks like. This is what your and statement looks like. And again, the and always connects in the middle. Let's take a look at what an or statement looks like. All right, this is an or statement. So we have X is less than or equal to -4, or X is greater than 2. This inequality is read as all numbers less than or equal to -4 or greater than 2. Now, when you go to write an or statement like this is exactly how it's going to look. You're going to have one of the inequality statements, X is less than or equal to -4. You always put the smaller number first, all right? So that smaller one, -4 compared to 2, that goes over to the left. Then you have the actual words or in the middle. Then you have your other inequality statement. Now notice that the arrows both point out, all right? That is going to be a closed dot here at the -4, because we want all the numbers that are less than or equal to -4. So or equal to, it's going to be a closed dot. The arrow is going to go out, because numbers that are less than -4, -5, -6, -7, they would all be in here. X is greater than +2. So no or equal to, so it's going to be an open dot, and the arrow is going to the right. We want all the numbers that are bigger than 2. So in an or statement, the arrows go out. This is what the actual statement looks like. There is no compact form. Like in the and statement, we had this form and this form with the word and or with the letter X in the middle. This is really the preferred way, that way that you'll see it the most often with the X in the middle. There is no compact form for the or. So it always goes the letter, inequality symbol, number, or, the word or, and then letter, inequality symbol, number. Go ahead and pause the video. Try these 4 questions on your own. So in this first one, it says water becomes non-liquid when it is 32 or below. So 32 includes 32. So that's going to be a closed dot at 32, or below 32. So the arrow is going to the left. Or, notice it said or when it is at least 212. Now you have to be at least 16 years old to drive a car. So it includes the number 16. This includes the number 212. So this is going to be a closed dot at 212 and the arrow going out. So that is an or statement. It includes all the numbers that are 32 or less, all the numbers that are 212 or higher. A number is greater than 4 and no more than 11. So greater than 4 is going to be an open dot at 4 going to the right, because we want all the numbers that are bigger than 4, not including the 4. And no more than 11. Now, no more than includes the number 11. No more than includes that number, because it can't be more than it, but it can be equal to it or less than it. So if it's less than it, notice those arrows are colliding in the middle. Since those arrows are colliding in the middle, we're going to connect these together with a bar so that it looks like that, and that is an and statement. A hot dog vendor has 300 hot dogs to sell. He needs to sell at least 150 hot dogs to make a profit. So he only has 300. That's the most that he could sell. So 300 includes the 300, because he could sell all 300 hot dogs, or he could sell less than that. He needs to sell at least 150. At least includes the number. You have to be at least 16 years old to drive a car. So that includes that 150, just like it includes the 16 or higher. Notice again, these arrows are coming together in the middle. So we're going to connect them with a bar, and it looks like that. A number is at most 3 or greater than 10. So at most, that's the most that it could be. So it includes that, or it's less than that, or it's greater than 10. So greater than does not include 10, and it goes out. So if we were to actually write these as or statements or and statements, let's take a look at what that would look like. This would be X is less than or equal to 32, and then the word or, and then X is greater than or equal to 212. That's what that statement would look like. Here's an and statement. So we're going to put this X in the middle. We have an open dot here. So this is going to be a less than. We have a closed dot here. This is going to be a less than or equal to. Our smaller number goes here. Our bigger number goes here. This is another and statement. So this would be 150. We have our X in the middle. We have our 300 at the end. They're always going to be less than symbols, but this is or equal to and an or equal to. So this is what the and statement would look like. A number is at most 3 or greater than 10. This is an or statement. So we're going to have the word or in the middle. We have the first inequality, which is X is less than or equal to 3. And we have the bigger inequality, which is X is greater than 10. Again, for the and statements, it always goes the smaller number, the inequality symbol X, inequality symbol, the bigger number. These are always less than symbols in an and statement. For the or statement, you always have the word or in the middle. You have the first inequality statement with the smaller number, the second number, it's the bigger number over to the right.